So let's move forward. So now we'll be discussing about some of the static. Again, as we mentioned, that static is when we use some sample to measure some summary, So the first thing we'll be talking about what you call measure of central tendency, So you are given a sample and you want to get a number that is a representative of that group. The first one is the mean, and mean is when you are given a sample, like for example the weight of the packages, and you sum them and divide by how many data points you have. So this is and of course you have sample mean, and also you have the population mean. Just drawing a graph because we'll be comparing against what are the other options we have. We have to keep it in mind that mean is not sometimes a fair representation of the data because average is easily influenced by outliers. We'll learn that. And the other one is the median. So you can sort these values in ascending order. So these package weights you have 3, 12, 22, 22, and 68. If you order them based on their weight from smaller to bigger, and you take the middle value as your representative value. So this is how we define the median. And if we compare against the mean, you can see that, as I was saying, that although we have only one number that is greater than the mean, but if you look at the median, you can see that if the median is 22, so you can see that almost it is the middle data point of your sample. And the other one is the mode. What number is the most occurring number? So for this case, the 22 happened to be 2 times, so that's why the mode is 22. Let's take a time to understand that why the mean can sometimes be not the right choice as your central value, or maybe the representative value of this group, because you might have outlier in the data. For example, let's say we are taking the measurement of the height of the students in this class, and so we expect that the average height should be around 5 and 6 feet. That's what I'm saying. Let's say there are 3 people in my sample. One is with 5 feet, one is with 6 feet, and the other one is, let's say, 6.2 feet. What happened to be that, let's say, when we are doing the data entry, there are some mistake. We forgot to put the point 6.2. We just put 62. So what will happen? Because if you take the average would be something around 40. Or maybe 30. But let's say the example that we are saying that, okay, 5 feet, 6 feet, and 6.2. So the average would be totally wrong. If we took the median, we made a mistake in 6. Even in that case, the 6 will be my representative data. So the mean sometimes can be a wrong estimate because that may actually be biased by some outlier in the data. Now we'll talk about variance and standard deviation. These are actually the same metric. Standard deviation is actually the square root of variance. So if you understand variance, you will understand the standard deviation. So variance or standard deviation represents how spread your data points are. What is the spread? So let's take an example. There are 2 groups of students. In one group, people only got A grade and B grade. In the second group, the students got A grade, B grade, and C grade. So if you compare these 2 groups, we can say that group 1 is stronger than B. Students has like more varying strength, we talked about mean, we talked about mode, and we talked about median. So those are measures of central characteristics of the data, and the variance is kind of how much spread the data is. Let's now talk about some of the notational conventions, because maybe in the coming days we'll use like some notations. So when you are talking about population mean, it is represented through Greek mu later. So you have n data points and you sum up them and you divide by n. And when you do the sample mean, you represent through x, then dash on the top. Then the variance is you estimate your mean and you take like how much a data point is from the mean. You do the square, you do the sum, and then you take the divide. So, and as I said, that standard deviation is just a square root of variance. So that's all for this part of the presentation.